Hello, how are you? Okay, this is where we left off in class, everyone. We left off with this equation right here in green, okay? This equation is called the vector form of an equation of a line, all right? So I wrote out here in words where we left off. This is an equation of a line, and specifically, when you have an equation of a line in this form, it is called the vector form of an equation of a line, okay? This line here describes all the points that are parallel to some given vector in any space, passing through some ordered n-tuple, okay? It could be ordered pair, ordered triple, ordered n-tuple. And here is that equation that you have in your book, although I don't think I ever gave you the formal title of the vector form of an equation of a line. Now I'm going to move on. This line can be written in vector form, but you can also describe this line using a set of parametric equations. Here is how. Okay, look above. Left-hand side, right-hand side. Here is the right-hand side right here. Okay, x naught, y naught, z naught are just the components of x naught, plus t times a, b, c. Remember, a, b, c are just the components of the vector that you want your line to be parallel to. All I did from step 1 to step 2 is I multiplied this vector v by t. I then added these two vectors to get a vector whose components are here, here, and here. You'll see I also dropped the dot, 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 just because it was being a pain. And when I get down to this point here, clearly you will see that if this vector equals this vector, then it must be that component equals component, which is what you've got right here. So when you're talking about an equation of a line, we can describe the equation of the line parametrically or in a form called vector form, okay? Now go ahead, please, to the attachment that you printed out. Let's just do a little bit of practice together, shall we? Okay, there should be 4 pages total. Go ahead, and I would advise stapling them in chronological order, in order. And if you're curious, this is actually taken from a multivariable calculus textbook. And I think these questions are nice. I like them a lot, all right? So, go ahead and let's see on page 829, let's do this together right now. Let's do question number 16, okay? So we're on page 829 of your attachment. Let's take a look at number 16 together. Let's read it out loud. Well, I'm reading it out loud. Maybe you will be too. I am looking for the line through 2, -1, 5, that is parallel to -1, 2, 7. And if you look at the instructions for this question, in the box it says, find the parametric equations of the line that satisfies the stated conditions. Well, for number 16, I want my line passing through 2, -1, 5, and I want that line to be parallel to -1, 2, 7. Well, I don't know how much easier it could be, because x naught, y naught, z naught is the point that you want your line to pass through. A, B, C in this context are the components of the vector that you want your line to be parallel to. So the equation of this line will merely be x equals 2 plus, well, let's do this, -1t, okay? Y equals -1 plus 2t, and z equals 5 plus 7t. And there you have it. That's it. Let's do a little bit more. How about this one? 13. I like 13. The line that is, I like this one, tangent to the circle x squared plus y squared equals 25. I want the line tangent to that circle. And I want the line tangent to the circle at the point is 3, -4. All right, let's see. Maybe you'll do a quick little sketch with me. X squared plus y squared equals 25 does in fact describe this circle whose radius is 5. 3, -4 is about right here. Okay. And the line that I'm looking for is right here. If you want to try this on your own, go ahead. I'd like you to do this. I want you to find the equation of this line, though. I'd like you to use vectors, please. Try and see if you can use vectors. And then, you know what? I'm going to override the instructions here. I would like the vector form of this vector form of this line. The vector equation of this line, okay? Go ahead and try it on your own, then replay me. So I want you to integrate vectors into this. I know you could do this using Algebra 1 or the equivalent. Don't use vectors. All right, here I go. So one thing that is interesting to me is, this point 3, -4, which is the point of tangency. I know for a fact, based on my prior knowledge with circles, that any tangent line is going to be perpendicular to the radius at that point of tangency, okay? And that radius, the length here is radical 5, yes, but also I could think of this radius here as a vector. In fact, I'll call this vector v. And vector v has components of 3, -4. And I know that if I want this red line to be perpendicular to vector v, and I'm going to call this, let's just say that this red line, I don't know, let's say there is a vector, I'll call this vector u, whose direction is the same as the line, okay? So, and vector u would be right there. I know that v dot u needs to equal 0 because they are perpendicular. So I think I'm going to do this. So 3 okay. So, and we're in 2 space, right, everyone? So the question is, well, 3, the dot product of vector v and u, or 3u1 plus -4u2, has to equal 0. Well, what could the components of vector u be? Yes, vector u could be these components, okay? And you can check if I dot product v and u, this would in fact equal 0. And this vector is the vector that the line L, which is this line right here, let's call this the line L, okay? Line L. Line L. Line L is parallel to vector u, and I have everything I need to create the vector form of this equation. The vector equation of the line L. So line L could be described by all the points x, y, passing through the point 3, -4, plus any scalar multiple of the vector that line is parallel to. Ding, 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 ding. Good job. I'm very happy. Okay, let's see. I would like you to try, let's flippity-doo-dah. Okay. All right, everyone, look at page 830. 830. Look at number 29. Number 29. Okay. Number 29, in fact, if you look at number 29, the question there is, in number 29, determine whether the lines, line 1 and line 2, are parallel. Let's add some notes here first, okay? If you know, let's just kind of use what we know. Let's see if we can use what we've written above with these notes above, and let's answer some thinking questions, okay? Let me ask you this question. If you had 2 lines, and let's say you had 2 lines that were both described parametrically. So you have one line described by this set of parametric equations, and you had another line described by a set of parametric equations, okay? Ladies and gentlemen, if those 2 lines were indeed parallel, what would you be able to say about the vector ABC of one line and the corresponding vector ABC of the other line, if the 2 lines were parallel? Yes, you would say that those 2 vectors would be scalar multiples of one another, right? So look at number 30. I actually don't remember what I told you to look at, but anyway, let's look at number 30. In number 30, look at line 1. Line 1 is this line. Z equals -2 plus 3t. Okay, and then this is line 1, and here's line 2. I wonder what time it is right now when you're listening to this. Is it spooky and dark outside? Are you having a late night snack? Are you eating a donut? Okay. All right. So here's line 1 and line 2. If you know that this line, this line is parallel to the vector 3, -2, 3, and this line is parallel to the vector 9, -6, 8. Okay? Question for you. Are these two lines, line 1 and line 2's, parallel? No, they are not. The reason why is, you'll notice, these two vectors, okay, they are not scalar multiples of one another. So line 1 and line 2 not parallel. Okay, now I'm going to ask this question. My question to you is this. In 3 space, because we are in 3 space, if two lines are not parallel, does that mean they must intersect? Let's bring it down a dimension. In 2 space, if two lines are not parallel, must they intersect? Yes. In 3 space, if two lines are not parallel, must they intersect? Let's see. Take 2 pencils. Go ahead, find 2 pencils. Hold them in the air, and hold them in the air such that they're not parallel, but you know for a fact they will never intersect. Okay? In 3 space, it is possible for 2 lines to never intersect and also not be parallel. That situation where 2 lines don't intersect and they're not parallel, that situation is called lines that are skew lines. Skew, oh my goodness, that's so big. Skew lines, okay, are not parallel, but still do not intersect. Okay, so part of your thought experiment, which is part of your homework tonight, is in this situation with number 30. I want to ask you this question. I know these lines are not parallel. I know I'm in 3 space. Can you think of a way to rule out the possibility of these 2 lines intersecting? Or in other words, can you think of a way to determine whether or not these lines intersect or are they skew? Which one is it? How do you think you go about answering that question? So this is not the question that was asked of you in the text, but I do want you to think about it and come back to me and see what you think. Do not Google this. Think about it. Please just think about it. Okay? All right. Okay. I would like to do this now. I would like to give you homework. Okay. Okay, hold on. Okay, so your homework for tonight is right here. All right. But you're going to want to have the entirety of this attachment printed out because I'm going to revisit it. All right. This is kind of just like, this is hovering like JV/varsity, leaning more towards JV. Okay. We still have varsity and some prep level questions to do from this packet. So don't just like do these questions and then take this packet and, feed it to your dog. All right. Do hold on to it. Okay. All right, very good. See you tomorrow. Goodbye.